Hello everyone, welcome to lesson 6, or thing 6, video 6 of this introduction to coding series, and today we get into making an actual program-like thing. We're going to dive into if and loops, just more stuff on program flow. This is where you sort of start to get into the whole, I get it, this is how you make a program kind of things. So we're going to talk about if, else if, and else statements. We're going to talk switches, do loops, while loops, for loops. Now, do and while loops, I might have to look up because I don't use them all that often, but I'm pretty sure I know how to do them off the top of my head. Once again, it's one of those things, unless you do it all the time, you kind of forget, but the basic concept is ingrained in my mind. So let's talk about program flow and what actually makes a program something that is useful. A program needs to be able to react to a user. There are a lot of really handy programs that don't. Things like benchmarks obviously don't react to a user. A prime example of that is prime 95, excuse the pun, which just works out a bunch of prime numbers just to stress your CPU. That's cool. I really can't think of anything else good. Maybe something that like calculates something. A lot of math things. But most programs respond to a user. You know, your text apps or your chat apps, how good would they be if you just couldn't interact with it? What would be the point? Or, you know, a video game, if you didn't have input into the game, you'd just be watching a movie, which some could argue that's kind of a trend now, but we're not going to get into that. So the way user input works is different depending on what you're sort of making, and learning about ifs and loops and stuff like that is definitely a big stepping stone into being able to take user input, or even input from a file, or from the network, or from the screen, or from wherever, and do something constructive with it. So we'll talk about the basics of it first, how it all works, the syntax of it, and then we're going to actually use it in something pretty simple. It's going to be something menu-based. Haven't really decided what. Kind of going to play it by ear, which is always dangerous for me, but we'll see how it goes. So let's talk about if, and by extension, else if and else. So an if statement is pretty simple, and speaking, you know, just English again, you could probably figure it out just what an if does. If something, then do something. That's it. So let's give you an example, okay? So let's pretend the user has given us their age. Int user age is equal to, let's say 30, because fuck you, that's how old I am. And then we're going to go, okay, well, we want to know, my dogs are sleeping outside. I think one of them just got up, and I don't trust him to not shit on the floor. So we want to test the user's age. So let's just say if user age is equal to 20. Now I'll explain this, how that statement works as right now. So we have if. Now anything in this like bluish, bright blue color, that is C++ syntax. And generally speaking, a lot of that blue stuff is pretty universal. C and C++ did set a lot of standards that people still use, which is fantastic for me because that's the first language I use, so it sort of flows everywhere. It's really nice. So the syntax is, and I'm going to use comments, if, this is always first. Oh, nice arrow, Jason. Always first. Because the first thing needs to point to the, to tell the compiler what you're actually doing. Then you have your open bracket, and then you have your condition. Now, the way a if statement works is it evaluates inside the brackets if it's true. That's all it cares about. It doesn't care how you come to the conclusion whether it's true or false, whether your thing is yes or no, we're going to do it, we're not going to do it. It just says, is everything inside of this bracket true? Does it evaluate out to true? I'll explain a little bit more as we go, but that is the basic gist of it. So if this thing is accurate, we're going to execute the code of the if statement. Otherwise, we're not. So if, then your condition, and this must evaluate to a bool. Nearly always. Nearly is very important, but we sort of got into a little bit of that on one of the last ones, but it doesn't matter. And then we have a close bracket. And now this part, I will go into a little bit more depth a little bit later on. But for now, let's pretend it's correct. And I say you always need the braces, okay? Because you don't always need the braces. But let's pretend we do. And just like a function, your code to execute goes in the middle of the braces. And that is your if statement. So this one here is saying, if the user's age is 20. Now, you'll notice this double equals. So this up here is your assignment operator. And I'm going to go into operators in like 4 lessons because it's not really that important. It kind of is, but it isn't. But you can sort of, well, I want to go in depth into operators a bit later on, but we'll go into a little bit now. So that's your assignment operator. They're saying, please make this equal to this. Now this guy here, the double equals, is the comparison operator. You can probably infer what it means from the title. It's saying, is this equal to this? Now, what it returns is usually, generally a Boolean. It doesn't have to be though. But in this case it is. Actually, I'm pretty sure it nearly always is. I can't really think of a reason why you wouldn't. Oh, excuse me. I think strings don't return a Boolean depending on what you do. I can't remember. It's been a while since I actually used C++. But in this case, it's going to say if the user age is 20, we're going to print out to the screen, hello, young person. Cool. Okay, so our user isn't 20. So we know what's going to happen here. So let's put some extra stuff in on the screen so we can see what's happening. Start with program. And end of program. Now, this little bit down here we've seen before. It's the stop code. We're going to actually go into a little bit of how that works in a second because we're going to be using it for constructive purposes. So let's run it. Take your time, mate. And it just says start of program, end of program, because I haven't put the new lines in. It doesn't execute that code because user age is not 20. So let me just put in my end lines because it's going to annoy me to no end if I don't, because I am a neatness freak when it comes to that kind of shit. Things need to be on new lines. Cool. So let's change the age to 30. Hello, semi-young person, and let's execute it. So now we're comparing the user's age to 30, and look at that. You'll see hello, semi-young person has come up. So it's going, okay, we've hit an if statement. Let's evaluate this thing. User age equal to 30 is true. It'll return a true from that operator. And then it goes if true, which yes, that means let's execute the code. Before, yeah, cool. Oopsie doodle. I can never, what key is that? Control D? No. Control S? No. A? No. Z? No. X. Yeah, Control X will delete a line, which is handy, but fuck, I do it too many times by accident. So this case here, is user age equals to 20? That is false. So then it goes if false. So the false says, no, we're not going to do this. I really hope that makes sense. I mean, it should, right? If user age is equal to 20, in your mind, if you're an English speaker, you're going to go, yes, I get it. The user age is not 20, so we're not going to do what's down here. Now, I'm going to go back on this little braces are required. In the case, if you have an if statement with a single line of code under it, and you only need one single line of code, you don't need the braces. So this here is valid. And if I put this in, semi-young person, and I execute it, you'll see it's going to do exactly what we'd expect it to do. The reason why I highly recommend you don't do this is, for one, consistency, because the amount of times you're going to have an if statement with only one line of code under it is, I won't say rare, but it's extremely uncommon. And for two, if you go something like this, and then you go, oh, I also want to print out, hehe, you are old. let's say you aren't old, and let's change it back to 20 to better understand my point. Whoop. It's actually executing that, even though in your mind it's like, well, why isn't it doing what I'm telling it to? Because it's not inside the braces. It only does one line of code. So if you do this, then you can keep adding lines in if you want to go like that. That's all fine. And you don't have to redo the braces and stuff like that. And so just for consistency and neatness purposes, I find this is much better. And any sort of company that has a style guide will generally say no single line uncurly braced if blocks, which is a really strong way of saying don't forget these, you idiot. And in my personal opinion, best practices, you should always have them. But once again, if you're only working with yourself, it doesn't matter. If you're working with other people, get a consensus. It's a democracy. Just remember that. It doesn't matter how senior you are, it's a democracy. Cool. So this is handy. I can do comparisons and I can sort of work on what data I've got to go one way or the other in code. But I mean, anywhere from 20 to 29 is a young person in this case. So what do? You know, how do we sort of go? Do I have to go if the user age equal to 20, and then I have to copy this and go the user age equal to 21? Oops, if I can type, and etc., etc., etc. Well, no, that would be extremely cumbersome and awful. So we're not going to do that. I'm going to introduce you to the world of other operators. So this comparison operator isn't the only one you have. The other ones you can use are not equal, less than, and greater than. And then greater or equal to and less than equal to. Those are your main 6, including the equals, that you will use for comparisons. So let's talk a little bit about them and how they work. So let's say we want to know if the user is under 30, okay? Everyone under 30 is a young person. So what we want to do is this, okay? Just like, you know, well, like 7th grade math or whatever you learnt this shit in, it's just a less than sign. It's your angled bracket. If user age is less than 30, then do this. Now, this is less than. So it's, in the math notation, it would be like, well, minus 2 billion or whatever it is, up to 30 with a bracket. It's anything less than 30. It doesn't include 30. If you wanted it to include 30 and have it like in this math notation, you can do less than equal to. And that's how you do less than equal to. The same also works with more than, that's more than or equal to. Then we have the last one, which is my favorite personally because I like typing it. Not equal to. So if you want to say this, you are not, let's go 20. You are not 20. So maybe you have, you know, a bar that only lets people who are 20 in, and you want to have some code to automatically work out someone's eligibility to get into this bar because you are an awful person. How do you do not equal to 20? In C++ and most programming languages and binary in general, there is something called an invert operator, which is the exclamation mark. So this piece of code here reads, if user age does not equal 20. Now in like proper math, you have the equal with the line through it to have not equal, but this is the coding version of it. Now there's actually a couple of ways you can do this as well, which I'm just going to run this to say, you know, we've done it. There you go, you are not 20. The inverse operator also works on its own. So if you have this, if user age is equal to 20 and you put it inside brackets. Now, I need you to go back to the lovely world of algebra, and I hope you've done algebra. Things inside, or even BODMAS back in like year 3 or 4, which is brackets of, well, okay, the O might be something different now, division math, a division, multiply, addition, subtraction, which is your order of operations. The bracket gets evaluated first. So this in the middle here, after, so it'll be if user age equals 20. I do that right. And that'll evaluate down to if false, because I am 30. All right. And then the brackets that appear because it's already been evaluated, so it'll turn out to be that. Now what you can do is with the invert operator, if you have a binary thing, which user age equals to 20 will come back as a Boolean, as a binary option, so it's false, you can put on the invert operator here, and it flips it around. It's just false is equal to true, true is equal to false. That's all this little guy does. So then this operator, this order of operation will go like this. If not user age equal to 20, if not false, if true. And then it's going to execute the code because it's true now. That's a very roundabout way of doing it, but it can be something you need to do pretty often actually, because you might have a very large list of conditions that you don't want it to be, and then you want to invert it at the end because of operations and stuff. But that's how that works. I'm going to leave that up on the screen. Cool. So that's how an if statement is. That's how it works. That's how we do cool things in a program. But we really haven't done, a whole lot. I mean, cool, we can test something. So let's make it an actual program, okay? So let's go and say the user age is -1. Let's initialize it to -1. We know if the user has entered something. And then we're gonna go, hey, listen, enter an age. And we're gonna get rid of the end line, and you'll see why in a second. And then we're gonna use this guy down here, cin, and we're gonna grab it from the console rather than printing out to the console. The way we do that is we go cin, the brackets going into the variable, and user age. Now cin is pretty clever. It's detected you want a number, and if I remember correctly, let's fire it up. I'm going to type in a letter, and it's going to go, you fucked up. I lied. It's not as smart as I thought. Why are you making me out to be a liar? Yeah, so it doesn't actually put anything into it. User age is still equal to -1. So it's a little bit clever like that. And we're going to go into why that's really important a little bit later on, but just keep that in the back of your mind. So let's go and ask the user age, and let's get rid of this horse hockey and go, if user age is not equal to 20, then end of program. Cool. So enter my age. I'm going to say I'm 25 because I'm delusional. Hey, you are not 20, end of program, and then ask for something. Cool. Let's run it again. I'm 20. It doesn't say you're not 20. Cool. And let's test 30 as well. You are not 20. Cool. Now, that's all well and good, but in this case, we're only sort of saying that we're not 20. We need to also tell them that we are 20 when we are 20. So this brings in something that's really awesome, in my opinion, in programming. It's called the else statement. And I want you to just sort of pause the video, imagine how it's going to work, what it's going to do, just get your thoughts thing, and just see if you get it right. Because I think you're a smart person if you're watching me, obviously. Cool, you got it? So an else is if the if conditions before it, very important. If you listen to my word there, I'll emphasize it. The if conditions before it don't evaluate to true, then we're going to execute this bit of code. Cool. So how do we do it? It's exactly the same as the if, pretty much. So else. Now, this doesn't require a condition because it's the anti-condition. It's none of the other things have happened, so now we're going to do this thing. But it's the same kind of layout. It's else, then the curly brackets. Now, once again, you don't need the curly bracket if it's one line. It will work, but please don't do it because it's fucking awful. And I can show you a bit of like obfuscated code that's just awful a little bit later on. So let's put this bit of code in. So if the user age is not equal to 20, then print out to the screen, you are not 20. Otherwise, you are 20. So let's run it. So 25, you are not 20, end of program. 20, you are 20, end of program. So how easy is that? You've put in a bit of user input and you're reacting to that input and printing out something on the screen depending on what it is. And that's cool, right? That's pretty cool. That's the very basic workings of an actual program, a program that's actually kind of useful. Not really in this case, but you can probably do a lot with just what I've taught you here. You could take input and you can branch the code based on what you're doing. You can go if true, if false. Now, if I was to write this, I would do it the other way around because I think this makes more sense, like this. Man, it'll do the exact same thing. What I'm saying is if you're 20, otherwise, rather than saying if you are not 20 or otherwise, because the if you're 20 is a more singular condition. It's the more specialized condition. So that's the kind of one you'd want to put, well, personally, at the top, if it doesn't matter what order they go in, because it can matter. And I will explain that when we get to a little bit later on. A lot of things are going to be explained later on, I promise. Okay, cool. So that's pretty simple, but what if we want to test if someone is 20 or if they're between 20 and 30, or if they're between 30 and 40, you know, all these things. We're going to say, you know, you're in your 20s, you're in your 30s, you're in your teens. That's what we're going to do, okay? So how do we do that? Well, we can do condition chaining. I don't know what the actual thing is called, but we're going to chain our conditions together because, I mean, as useful as this is, there's usually more than one thing you want to check. Like if it's a men's only bar, you want to check if they're over 18 and if they're male. That's two things, and it's a pain in the ass if you want to do, you know, a little bit of weird code, which I should actually explain myself. You can nest ifs. And let me explain that before I go on. Oh man, this is going down the shitter quickly, isn't it? Inside of an if statement, you can have another if statement. So you can say if user age is equal to 20, and if user age is equal to 20 again, or 30, which let's do something that makes a little bit more sense. All right, let me just quickly write this out. You are not old and not 20. So this checks if your user age is 30 first, less than 30 first. Then it checks if your age is 20 and then does the same thing. Your if statements are much like functions in the way they call. They sort of stack on top of each other. But there's a little caveat here, okay? So if you were to have just this, okay? So if the user age is equal to 30, and then if the user age, if the user age is less than 30, and then if the user age is equal to 20. If you are 21, it's not going to go down here. The indentation is a really good way to think about this, simply because it does sort of format the code in a way you can sort of visually see what's going on. How else do you see things? Audibly, I guess. That's stupid. But this if and this else statement are tied together. This one is on its own. This does not tie to this. Just because this one is false, it means that this particular block of code doesn't execute. But this one has already come to true, so this else statement will not execute. And let me explain, or let me show you what I mean. So I'm going to say I'm 21. It's just going to go straight to the end of the program. Because it's gone into here, and it's gone, sweet, this is successful, cut the else off, that's never going to happen. Then it's gone into here and goes, okay, that's not successful, jump out to the bottom where we were before. It can be a little bit confusing. But like if you think about it, you're going up to someone, okay, are you 30? Are you less than 30? And they go, no. You're going to tell them you're not 20. If they say, yeah, I'm 21. Cool. Then you're going to go, are you 20? No, I'm 21. Okay. I don't know what to do now. Because you haven't written out that particular block. It's a little bit to get your head around. I struggled with it a little bit when I started as well, that these two things do not match each other. But at the very least, try to match your indentations. The way Visual Studio and pretty much every IDE does your code will be very similar, and it's very helpful to sort of look, these are on the same level, they match up. This is on the same level, it matches up. But once again, these two don't match up because they're not directly connected. They've got stuff in between. And I really hope that makes sense. I struggle to explain this in a cohesive kind of manner. But, I just figured it out. I figured it out. Are you ready? Okay. Pretend you're walking down a footpath and you're at an intersection. You can go left or you can go right. That is what this if statement is. You go left if you're under 30, you go right if you're not. Cool. Then you go down that left intersection and you're at the next intersection. You go left if you are over 20 or if you're exactly 20, or you magically appear down some other path. Oh man, this is really confusing. It's a matter of trying to explain the way the code actually works without sort of being too stupid, but also being too smart. Let's just move on. If I think of something better, I'll come up with it. But that's how if statement works. You can go as deep as you want. You can go... This would be pointless, but you can go, if 21, 22, this would never work. But yeah, there we go. So let's go back to what we were talking about, which was nested conditions. Just turn my phone on silent. Cool. So you want to test what decade they're in. Now there's a couple of ways we can do it. We could probably cheat a little bit, but we're not going to. So let's go, okay. Let's start from preteens. I forgot the name of it. So if you are less than 10, you are a preteen. I'm going to count 10, 11, and 12 as teenagers. No, I'm not. We're not going to do that. We're going to go less than 13. You're a teenager. You're a preteen. Between 13 and 20, you're a teenager. Then you're in your 20s, your 30s, your 40s, your 50s, 60s, 70s, 80s, 90s, 100s, 100. We'll go up to 50 just to make it a bit more brief. So, well, let's start with the easy one. So, if the user age is equal to -1, why are we doing -1? We are checking that the user's not an idiot. But that's wrong, isn't it? Because you could put in -3, and that would be really stupid. I am -3 years old, duh. So if you think about ages, what are valid inputs? Basically anything from 0 to, a billion. No one's going to be a billion years old, but it's technically valid input, right? You'd probably clamp it at like 120, 130. But we'll clamp anything from 0 to 50 is valid input, okay? So everything less than 0 then is invalid input, and you can probably imagine how I'm going to write this next statement. -1 will mean they've either typed in -1 or they've given us no input or invalid input. So, and anything less than that is also invalid. So we're going to go anything less than 0, less than 0. Now it's less than 0 because 0 is still a valid age. I mean, when you're born, you're 0 years old. When you are 364 days old, you are technically 0 years old. So we're going to go, you fucking drongo, into a proper age next time. If you don't know what a drongo is, you're not Australian enough, and I apologize. Cool. Now, here's the fun bit. We want to know if they're between 0 and 12, inclusive, okay? Now there's actually a few ways we're going to do it. We're going to do it the long way first to sort of go through chaining, and then we're going to do else statements, or else if statements to show you how they actually work. So cool. So then we're going to go if the user age, so the first condition is more than or equal to 0, okay? Now, we get to learn 2 more operators now. We have the AND operator and we have the OR operator. Now there is actually there's two of them for each. There's the AND and the OR, and then there's the binary AND and the binary OR, which we're not going to be using probably for a while or ever. It's not something you generally use a lot. I think I've used it like 4 times since I started coding. It's an extremely like rare thing to use unless you're working very low level. But we'll go into those at some point. But the ones we're going to be using is AND OR. Now, once again, you can probably figure out how this is going to work in your mind. You're going to have 2 conditions if the user is between 0 and 12. I'll say it again. If the user is between 0 and 12. Yeah? So the AND operator is your ampersand twice. Okay? And then what's our second condition? If the user age is less than or equal to 12. Now you might have thought, well, why can't I just do this? Because these 2 statements are independent of each other. Because you might say, as I said in the example before, if the user age is more than 18 and the user gender is male, that kind of thing. They're not the same variable, so you want to have that sort of separation. It does become kind of cumbersome if you're going to go, if the person is alive, if the person is 18, if the person is male, if the person is wearing clothes, if the person isn't banned from it. So you have all these variables that are the same. It's a person. You just type them all in again. But that is actually quite a rare thing in my opinion. You don't generally check that many things on one guy, on one piece of data. But I mean, it depends on the program you're doing. So let's read through this bit of code. And let's also put all that down there because I'm not going to need that at the moment. So if the user's age is more than or equal to 0 and the double ampersand is your AND, a single ampersand is binary AND, which if you've ever done binary math before, you know what that is. If you haven't, then you don't have to worry about it for the moment anyway. And the user age is less than or equal to 12. So cool, let's do our proper if statement, and let's see out you are a preteen. The exclamation point makes it feel creepy for some reason. Cool. And let's just keep going. Let's copy and paste because we're lazy. Control-C, Control-V is probably the thing I've used the most in my entire life, when it comes to my professional life at least. So what are our conditions for a teenager between 13 and 20? Now, we can get creative, we can go less than 20, or we can just do it and keep consistency, which is important, and say less than or equal to 19. If you are 13, 19, anything in between, you are a teenager. So it looks a bit different. Cool. What's our next one? Between 20 and 29, you are in your 20s. And I copy and paste this one so I don't have to type that again. Then 30s, 40s. Cool. So between 30 and 39, between 49 and 40. Now, it is very important to note that with an AND, both sides need to be true. That should make sense in your head. But the order in which you do them, it doesn't change the outcome. So if you go like this and flip these 2 around, if I can click properly, oh good lord, that's still the same. You're saying if you're less than or equal to 49 and more than or equal to 40, it's still the same, it's just backwards. But once again, for neatness, we will put it back because that's going to give me the absolute shits. So 30s, 40s. Now here, think about it. Can we use else? I'm going to put it in. So let's go else. Because we want to do everything above 49 is we don't care about you. You are too old man. Get out of my house. Cool. But will that work? I want you to think about it. How I talked about if statements before and how they apply here. And let's sort of go into a little bit more about it. So an if statement on its own, it just evaluates itself and then it moves on. Now we have 1, 2, 3, 4, 5, 6 if statements here. When you start an if, that is a new block of branches. It is a new set of paths you can take. You can put as many sets of paths as you want, but when you say if on its own, you start a new set of, paths. So this here is actually going to go through and check if you're less than 0. And even if you are, it'll still check if you're between 0 and 12. It'll still check if you're between 13 and 19, etc., etc., etc. And when it gets down to here, it's going to go, are you between 40 and 49? It's going to be, if I'm 30, it's going to say no. It's actually going to tell me I'm too old because this here is joined together, but these all aren't. So these two will be, this will be false, so then it will do the else, and let's sort of demonstrate that. So let's say I'm going to put my proper age in, 30. You're in your 30s, you were too old, and then the you are not 20 relic from before, which I'm going to delete now. Please go away. And I'll just run it again quickly. See, you were too old, get out of my house. So we can't use the else here. We have to actually explicitly do an if. If user age is more than or equal to 50. And I should format that properly because it's going to piss me off, like that. And now when I put in my actual age, it says I'm 30 and it just ends there. So if we do something else, just say we're 20, we're in our 20s. Let's say I'm 12, I'm a preteen. Let's put in a letter, you fucking drongo, then it X out of the program. The reason it X's out of the program is because this here is waiting for a character and it's got one waiting in the buffer because we haven't actually cleared the buffer. It's a bit of a quirk of the way cin works. And I don't remember how to actually clear the buffer off the top of my head. I'm just going to quickly look it up. Cin clear buffer. Because once again, I have not used cin properly in about 10 years. So apparently it's that. If I do that, I type in some letters. No, you lied to me, internet. How actually dare you? Apparently that. Uh-oh. Okay. This is funny because, as I said, I very rarely use cin because I do everything with Windows, with graphical user interfaces. Ugh. You suck. It should just be clear, but it doesn't seem to want to work. So I'll just put it in again. Maybe I did it wrong. That seems right. I don't know why that doesn't work. It doesn't matter. It doesn't matter. Cool. So this has worked, but this is actually quite messy and quite inefficient. Because as I said, each one of these if statements aren't bound to each other. So it'll check if you're less than 0, it'll check if you're between 0 and 12, between 13 and 19. Doesn't matter how old you are. At no point does it say, cool, we found our answer, fuck the rest. So then we get into the magic of else if. So what is else if? Now, once again, think about it, try to parse it in your brain using the English. We have if and we have else, and we know how they work. They're bound to each other. So what's else if? Well, think about it in terms of what we just wrote as well. If you're less than 0, then you're an idiot because you can't type. Otherwise, we want to check if we're between 0 and 12. Else, if we're not that, we want to check if we're between 13 and 19. You can sort of see where this is going. The else if binds a bunch of if statements together. And when you bind a bunch of if statements together, only ever one of the conditions will be true, and that is only when it will be executed. So let's talk a little bit about that and how we convert what we've got here into else if, and what's the advantages and disadvantages. So the advantage of it is, how we convert it is, an else if is just literally the same thing, except we do this. So we stick the else in front. This has now bound these two together. If I do it here, this has now bound these three together, and so on and so forth. They are now all bound together. In the case of more complex logic, so what can we do? What is a good example of this? Okay, so think about it in terms of you're checking someone's driver's license, you want to know their gender and their age, but you also want to know if it's valid, a valid driver's license. You can go, is my driver's license valid? Is my driver's license not valid? Kick them out. Otherwise, go and check their age. Go and check their age and their gender, or whatever you want to do. You don't want to go and bother checking their age, checking their gender, if the driver's license is a fake. I mean, what's the point, right? It doesn't matter. They're using a fake ID. They're probably underage, and you don't care because it's not valid for the liquor laws in your state. Let's get political. Now, the complexity of checking for someone's age is obviously not very hard. You sort of look at it and it says 1987, oh, they're 30 or 31. But there's a little bit of complexity to it. You have to actually work it out. Now, think about it in terms of, you're checking a picture and you've got a picture scaler and you want to downscale. Now, picture downscaling can be quite CPU intensive. I don't know why I'm using my hands. I turned Italian for some reason. Image downscaling can be quite expensive. And you go, well, I don't want to do it if it's, super, super big. It takes up too much time. And I don't want to do it if it's super, super small because there's no point. So you don't want to go and resize it and then sort of check it. Or you don't want to go and say, do too much work to it. So you check it. And then you go, okay, I've checked if it's too small. Now I'm going to check if it's too big. But if it's already too small, I don't need to check if it's too big. I'm just wasting CPU resources checking what it is. So how does it work in the case of this? Now, comparing an int to an int, it's pretty much nothing. I think it's like 1 to 2 CPU cycles. Like, it's ridiculously cheap. And when you think about CPU cycles, that's your gigahertz. If you have 3.8 gigahertz, you have 3.8 trillion. So hertz is 1, kilohertz is 1,000, megahertz is 1,000,000. Yeah, gigahertz is 1,000,000,000. Yeah, so 3.8 billion cycles. And you got quad core, so it's 4 times that. So that's a lot of cycles. And so 2 cycles is really a drop in the bucket. Whereas doing image downscaling might take you trillions of cycles, which is only 2 or 3 seconds, or 10 seconds. But in this day and age, that's a lifetime. So you don't want to be doing that if you don't have to. It's a really bad example. I know you could probably think of one better in your own head. But to be honest, I'm a bit burnt out thinking at work. So the brain's a bit on the fritz. We'll continue though. So it binds all these together. As a result, we can actually clean up this code a little bit. So we've already checked with all our conditions that we're going to print out something. We don't need to now check if the user age is above 50, because if we've come down here, it's not less than 0, it's not between 0 and 12, it's not between 13 and 19, etc., etc. It's going to be above 50. It has to be. There's no other condition that will make this work. We can now drop the if, and it's now just an else statement. So it's one less evaluation we have to do. Once again, it's a trivial evaluation, but you don't need to do it, so don't do it. Cool. So let's run this piece of code. Where are you going? Okay. Enter an age. I am 21. You're in your 20s. It works exactly as you'd imagine. Cool. So when do you use else ifs? You can use else ifs when your logic is bound to each other. It doesn't always have to be, it's an exclusive thing, so we'll do it like that. It could be the case of checking the license. The logic is bound. You're not going to bother checking the age unless the driver's license is valid. You can nest your ifs to do it like that, but that's ugly. This is kind of a little bit more clean. And there are a million other plethora of ways. Well, there's a bunch of stuff you can do with them. Now, the cool thing you can do is you can go over here and say if the user age is equal to 30, let's comment out this line, you legend, because I am 30, so you fucking legend. Now, in the previous case, why does it keep doing that? If I left it as if this, there'd be two true conditions, and there still are here. Let's go back to the code. If the user age is equal to... See, this is a very common error, missing the double equals. And that will evaluate to true, believe it or not, which is a pain in the ass, unless they've changed it. I don't actually remember. The way it works is... stop doing that. Cool. So if we enter 30, it's going to go here, and that will be true. But this here is also true, but because it's bound by these else's, it doesn't bother checking these. It's already got its true condition, so it's going to fuck off out of here. So if I enter 30, you fucking legend. It doesn't say I'm in my 30s, because that'd be rude. But it says I'm a legend, because it's true. So you can do things like that. And there are obviously times you're going to want to do stuff like that, and times you won't. And it's all dependent on your situation. And the one thing I've been thinking about a lot is what actually separates someone who just knows how to code between a software engineer or a programmer. I think software engineer sounds a bit wanky, but that's my title, so whatever. It's the ability to be able to code for the situation you're in my opinion. If you know how to code, but you don't know how to apply it to real world situations, then you're fucking useless. But if you can go, all right, I can break this down into logical and critical steps, and I can transfer that to code. Even if you need to go onto Google to look up things like how the CN works. I mean, as I said, I haven't used it in, it has to be at least 6 years. But I know how to apply it. I know what I need to do. I just can't remember the exact perfect way to do it. Or if it's something like at work a couple of days ago, I was trying to use a web client to communicate between two things via the internet. I know what I needed to do. In that particular instance, I didn't know what tools I had available and how to actually use them. So I had a quick Google search that says, hey, this is the tool you use and this is how it works. I'm like, sweet, I'm on my way because I know what I'm doing. It's not about knowing perfectly how every little thing works. It's about knowing how the language works, how the situation you want to program for gets broken down into logic, and how to combine those two things together. Google is not your enemy. Stack Overflow is not your enemy. C++.com is definitely not your enemy. References are good. Other people's help for little tricky things are always good. And there is no shame in having to ask for help. That is how you learn. And especially when you're not doing things very often, non-common things like stuff you don't always do, like CN. I don't use console, so I don't use it. There's nothing wrong with having to look it up. So as long as you know what you're looking up and what you're looking for, you're golden. Cool, so that's been 50 minutes talking about ifs. Good God. So this program is kind of useless, right? It exits. If you could imagine a bouncer checking IDs, and every time he checked a single ID, he just pissed off home, and you have to go drag him back every time. How fucking annoying would that be? You'd tie a rope to the bastard. So how do we make it continue? And how do we do cool stuff? All right, I'm going to leave that on screen again. We're going to do what's called a loop. So a loop, once again, think about it in your head, how it works. What does a loop do? A loop is something that it loops, it keeps going, just like a tape or a recording. Jesus, a tape, yeah, I know, I'm 30. It'll just keep looping until some condition. It works much like an if, but it just keeps going around. Now, there are 3 kinds of loops, and they're all applicable to different situations and all applicable to the same situation sometimes, depending on what you're doing. They are the do loop, the while loop, and the for loop. The do is also called the do while loop, and I'll explain, well, you'll see why. So let's go and say, all right, this is going to be our loop. We're going to ask them to enter an age, and then we're going to process their age. Cool. So how do we do a loop? Well, the syntax to a loop is very similar to the syntax for if, in the way you put your loop starter, your keyword, then you put your braces, and in this case, the condition goes at the end, and I'll sort of show you that. So, well, depending on how you're doing it. So you have your do loop. Now, a do loop is a loop that enters, does some stuff, then checks if it's finished looping. A while loop is something that checks if it's finished looping first. Then it executes the code if it hasn't. So think of the situation where you go, I need to see if it's 12 o'clock. It doesn't matter, you just walked out of the toilet, you need to check if it's 12 o'clock, otherwise you're gonna go back to work. Or otherwise you're gonna go to lunch, sorry, if it's 12 o'clock. You don't wanna go back to work first, do some work, and then check if it's 12 o'clock, because it might be 12:05 by that point. You wanna check what the time is before you go and start doing your work. That is the difference between a do loop and a while loop. The while loop, check it first. The do loop will just do it blindly, then check. For your situation, you have to work it out for yourself. In our situation, we want to use a do loop because we want to ask the user for the input, then do all the processing, then see if we want to exit. And I'll show you that. So let's do it. So how do we do a do loop? So a do loop is this. IntelliSense is amazing. Do, open curly braces, some code, close curly braces, while, condition, and then semicolon. The condition here is exactly the same as the if. So if you put this in here, if you would expect this to be, sorry, let me say it again. It's the same, except it's looking for a false, where an if is looking for a true. So we're going to keep looping while this thing is true. It'll exit when it's false. So in the case of this, if I do something like this, and this is something you may want to do. This is this is classic input validation. Keep asking the user for proper input until they give you something that you can actually fucking use. So let's just actually quickly run it and see how it works. So I'm going to just use the return keyword to exit the program there. Why? Oh. I forgot how to program for a second, apologies. Stop doing that. Enter an age, -3. You fucking drongo, enter a proper age this time. Hey, enter an age, -5, you drongo. 0. And it's gone off and exited because we're no longer less than 0. In this case, you would do this validation down here, which, let's actually just do that. So here we go. We're doing actual programming. Enter an age, -5, you idiot. Enter a proper age, 20. Wow, that was dumb. You were in your 20s. I'm dumb. I've got this the wrong way around. A little bit. This is the life of a programmer. No matter how good you are, you will make the stupidest errors and you will feel stupid forever. Man. So there's a couple of ways we can do it. Let's do it the easy way so that I don't have to double up code, even though I kind of am. Oh, I don't know why it keeps exiting like that. Okay, so -3, -5, 20. Sweet. We have input validation on our code. So how do we keep processing things? Well, first what we're going to do is this. Get rid of that. And reformat that and delete this. So what have we just done? We're saying do all this stuff while the user is still entering a stupid age. Now, this doesn't work anymore because now we're checking the actual age. And we're going to tell them if they're stupid anyway. So we want an exit condition of this program. So we're going to say, hey, enter an age or enter 19, I got to use the magic number, 99 to exit, okay? And then we're going to go down here and say, while they haven't entered 69. So let's read through this bit of code and sort of go through it step by step. So it comes into the do while loop. That's why it's called a do while loop. It's going to do this at least once. It's going to go, hey, enter an age or enter 69 to exit. It's going to take the age. It's going to do all this fun stuff. And then it's going to check if the age is 69. And if it's 69, it's going to exit out. So it'll be true if the user age is not equal to 69, it will keep looping. And if the user age is equal to 69, it will be false. The while will be false. It will exit. It can be a little bit to get your brain around, but I really hope you're following along. So let's run it. Oh, my Lord. So let's enter the age -4. You fucking drongo. Okay. Enter the age 5. You're a preteen. Let's enter the age 25. You're in your 20s. Let's enter the age 45. You're in your 40s. That's 55. Too old. 60. Too old. 69. You're still too old, but now you have to end the program. And that's the way it works. That is how you do a menu system, basically. Think about any kind of terminal menu you might have used, which I know, it's a bit long in the tooth now. We're getting a bit sort of over console windows, but if you've ever used like, like an old ass game where it goes, hey, enter this big list of shit. It'll just enter one thing at a time in a menu. This is basically how they work. And I've actually written games and menus just using this kind of thing. One of the first things I did was create a battleship game using just a loop and some if statements, and it was pretty fucking fun to my standards. And because I wrote it myself was probably why it was really fun. So let's go a while loop. Okay, so how do we do a while loop? And what is the difference? Oh, good Lord. I won't lie to you. I have forgotten what the syntax for a while loop is, and I was correct in my assumptions, so I shouldn't have doubted myself. Now, in the case of, apparently I've been working out for the last 50 minutes. 55 minutes, so since I started this video. So, a while loop is, the condition is actually at the start. That is the difference, and there's no do. So it's just that. Do you actually need the semicolon? I don't remember. No, we don't. Okay. So you could see it, and in the logical order of things, you can also see the way it works too. While the user age is not 69, keep going. Now, in this case, it's going to do the exact same thing because we start off at -1. But if we were to start off at 69 for some reason, this will never execute. So let's sort of go into that now. It's actually just gone straight to the end of the program because it's checked it first. Whereas if we convert this back to a do loop, like this, oh my God. See, it's still asking me that initial question. We're actually gone into the loop. I pointed out the screen like you can see here. We are here at the moment because a do guarantees it happens at least one time. Once again, it's all based on what your situation is, on which one you use. There is no right or wrong, generally. So it's all up to your objective nature, which one you actually need to use. In this case, either will work, but a do loop is smarter because you at least once want to ask them what they want to do. You don't want to go, maybe they don't want to actually enter the menu. They've opened your program. They want to use your menu. Whether they did it accidentally or not is up to them. But then I just type 69 and they'll exit. There's no point. There's no way you can just go, oh, let's quickly check if they want to exit first because we don't know. We haven't actually asked the user anything. So it's kind of silly. So let's go back to that. So that's cool. A while loop is more useful for, say, you're then going to base something off their age. So we're going to print out a number for every year they are. So we're going to go while the user age is more than 0, and I'll show you the code here. Cout 1 or I. Sure. Now, if they are 0, this won't actually ever run because they're not more than 0. I don't know if I the last bit. User age equals to user age minus 1. Let's put that in here. You can also nest everything. What am I doing? So we're gonna ask them for their age a second time, but so I've just commented out this whole bit of code here. I don't know what the shortcut is on normal Visual Studio. I'm using a plugin, so don't ask me. It's like Control K, Control D or something ridiculous. I don't know. Control K, Control C, I was close. I can't remember how to undo it now. KU. Cool. Shortcuts are good. Learn them all. Oh, why did it like change all my formatting? That was really weird. I think Control D, Control K, Control D is formatting. All right, so let's do this one. So 69 isn't going to exit, so we'll just ignore that. So 4 is printed I. Cool. Let's change it to an uppercase because it looks fucking ugly. Let's enter 0. It never actually does anything because we're already at 0. I hope that makes a lot of sense. It makes a lot of sense to me, but I've been doing this for more than half my life, so that makes a bit more sense why it makes sense to me. So that is your difference between a do and a while loop. Now there was a third one. There was a for loop. So let's quickly get into that. Let's comment that out. And let's leave that there. Okay. Well, actually, let's comment that one out as well. Let's uncomment that, copy it. Yeah, I'm going the long way. I'll get there. Give me a second. Cool. So we're still going to ask the user their age. And I'll just clean up that a little bit too. So a for loop is like an if and a do while loop combined. Sorry, a while loop combined. You can do cool things, mostly iterating. Now, iterating is in programming just going from element 0 to element 1 to element 2 to element 3, etc., 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 until you get some condition where we say stop. It's extremely useful when you're going through a list of things because you can go first item on the list, second item on the list, third item on the list, and do the same code for all of the items on the list from start to finish, which is an extremely common thing you do. You might want to print it out on screen, you might want to display it in a text box or a table, or maybe you want to print out, if you have a bunch of people's records, so 100 people's ages, you go, okay, for every single person in the list, print out their age. And it'll be 3 lines of code to do that. 2 to 3, depending on how good you are. So let's talk about a for loop, because a for loop is a pretty out there concept compared to what we've done before. So far, so good. So what makes the for loop different? Well, a for loop has 3 stages. It has initialization, it has the check, and it has the increment, or the end thing that happens. Explaining it well, I know. So let's go through it. So let's do our creation. Now, you're not always going to want to use this one, it depends, but when you iterate through things, you usually have an iterator or a number so you can keep track of where you are. So in the case of, shit, I got nothing on screen to really do with. Okay, I do have one. So we're going to create an object here, just like a normal create a piece of data. Int I is equal to user age. let's make it equal to 0 to start from, okay? Then we do a semicolon. So now in our second part, which is our end condition, much like the while loop, when this becomes false, this is when the for loop will terminate. So we're going to keep going until while I is less than user age. That's when we're going to stop when the I is no longer less than user age. So when we hit the user age that they've inputted. Cool. Then we do a semicolon. This last one is at the end of the loop. This will happen always. In the case of iterating through elements, you always want your I to be I plus 1. So we can go I equals I plus 1. So let's go through this again. Let's create a variable called I and make it equal to 0. Then while I is less than user age, we're going to do this code that is written in here. And then at the end of it, which is when it gets right down to the bottom, the very last thing happens, we're going to run I equals I plus 1. So the first time you go through the loop, I is 0, beautiful. Then it's 1, then it's 2, then it's 3, then it's 4, then it's 5. You can see how useful this would be. This is going through a list of things. So you can go list element 1, list element 2, list element 3, list element 4. But you never have to change the code. It'll just be list element I. And you can go list element I, print out the name to screen or something. It's a little bit of a highbrow concept in terms of coding, and it's extremely useful. The for loop is probably the one I use the most, because you go through shit. You go through a list of items to check things all the time. So what are we going to do? Let's do much the same as this while loop up here, because it's pretty much the same thing, except we're going backwards. We're going from 0 to user age rather than user age to 0. And we're just going to print out I. So let's do it. I really wish it would stop doing that. So let's enter 40. Is that 40? Yeah, probably. It'll be 39 of them. So it's gone through, started at 0. So once again, we can test with 0. It's not going to print out any I. It's going to do the same thing. In this very limited case, you're going to say, why not just use a do loop or a while loop? And you're right. In this case, you wouldn't use a for loop. That's a pretty stupid example. But to show you an example where you actually use it requires a lot more complex kind of things. And I believe in the next episode, we'll actually be using a for loop properly, which will be fun. But that is the basic concept. This for loop is a pretty out there concept for C++. It doesn't really fit any of the other archetypes the way anything else works. Nothing really works the same way as a for loop does, at least in the way it's declared. Obviously, you can make a while loop do the same thing, you make a do loop do the same thing, but the way it sort of crunches all this common shit together is extremely useful and extremely cool. So I do want to talk about one more thing. Those two buttons up there, if you can see my mouse, are the comment and uncomment buttons. I don't know if they're there by default if I've turned them on, but it is the text editor toolbar. So you can add in extra toolbars there. So text editor by right-clicking anywhere at the top. Cool. Visual Studio is awesome. I don't know why people give Microsoft so much shit. There's probably good reasons, but we'll sort of continue on. Now I'm exercising again, apparently. So let's talk about, the last thing I wanted to talk about was a switch statement. Not a Nintendo Switch statement, because they'll do an announcement and they'll get sued. But a switch statement. Now, a switch statement it's not always extremely useful, but it can be extremely useful. It is a sort of, it's an if statement, more or less, but with some funky shit added on top. So let's copy our stuff. And if you're wondering what I did there, if you hold Alt, you can drag like up multi-lines and stuff like that. So you can sort of grab around that. If you want to just delete these, you can do that kind of thing. Or if you wanted to do multi-line drifting and do like, which is extremely useful, believe it or not, you hold Alt and you can sort of drag and do cool stuff, which I believe they added in like 2012, and it's in stuff like Notepad++, which if you don't have Notepad++, it's extremely useful as well for just opening text files and stuff. Anyway, so a switch statement. So up here, we did a couple of if statements, and you know it's kind of messy, but it's a necessary evil to do it the way we want to do it. Let's say we just wanted to check if you're between 0 and 10, or let's make it a bit easier, 0 and 5, and give you a different answer based on what you are. We could do if user age is equal to 0, else if user age is equal to 1, yada 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 yada. But this is very time consuming, it takes up a lot of space. So let's do something a bit different. We're going to use a switch. Now I'm going to type it out and then we're going to go through it. So switch user age. Cool. So what is the switch here doing? Okay, it's saying check this condition, switch on this condition. Now in C++, switches can only be done with integers or numbers in general, I think. Don't quote me on that one, I'm not too sure about using floating points or doubles. Or on enums, which we haven't got into yet. But essentially they're integers anyway. In C#, you could do it on stuff that like strings and other things, but at that point it's not really worth the effort in my opinion. And switch statements in general aren't really worth the effort for the most part, but it's something you can see, so we'll go into it a little bit. So it's saying check the user age. In the case that it's 0, do some code. So let's say you are 0 and you are using a computer that's amaze balls, because I am a hip trendy lad. And this break here is important. The break says we are now finished, jump out of the switch statement. And I'll show you why that's important. So let's enter our 5 conditions. Cool. I mean, I'm not going to change these. I'm too lazy for that. So this all works the same. If you're 0, do this. If you're 1, do this. 2, 3, 4, 5. And then we have this default. Now, default is the else of this if statement. So it's saying if you're not any of the conditions above, you aren't young. Lol. Then do this condition. So let's just run it and see how it works. So as you'd expect, if I type in 0, it's going to say you are 0 and using a computer that's amazeballs. I regret typing that, to be honest. It stayed up there this time. So let's type in 6. You aren't young, lol. I find this offensive. But it's gone out to that default case down here and then ended. So as you can see, it works much the way an if statement does. But here's where it differs and where the breaks come in. Let's just say you have something that says, I gotta rearrange this. One moment while I rearrange this to make much more sense. Actually, did it make sense that way? You are born. You are 1 or more. You have been born. Okay, I got it. This all makes sense. Let me just quickly type it. Cool. So the break says, at this point of the code, jump out of the switch statement. And this actually works in loops as well, and in if statements, I believe. I don't actually remember. A break literally breaks out of the current like statement. So if I put a break in this for loop, it says if user age is equal to 50, I'm just going to stop doing it for whatever reason. So if you enter 51, it's going to do it once. If you enter 49, it's going to do it 49 times. I know, a little bit confusing, I apologize, but we'll just keep going. If I take out these breaks, what happens here is this turns into if this, if, and if this, oh, sorry, try that again. If this, do this, and also do all these things, because they're all below it. It only jumps in at the point of the age. I have to put this the other way, don't I? That makes more sense. Man. So I type in 4, it's going to say you are 4 or more, 3 or more, 2 or more, 1 or more, and you have been born. If I say 2, it's going to jump in here and say you are 2 or more, 1 or more, or you have been born. So let me demonstrate. Stop doing that. So I'm typing 5. What? Shit, it's 4. I'm so old I forgot what fucking numbers I used. So 4. There you go. So it's got all of those things. And if I do, oh, good fucking God, 2, it starts at 2. It starts here and keeps going down. These are the occasions when switch statements can come in very handy, because it stops you from going if the case is more than 4. Or if the case is less than 4, do this. If the case is less than 3, do this. If the case is less than 2, then do this, etc., etc., etc. It sort of allows you to chain all those things together. You could use this as a, like, if you've got a menu and you say option number 5 is to print out some text, and option number 6 is to print out some text and ask for user input. And option number 7 is print out text, ask for user input, and print out more text. And you're doing the same thing over and over again, so you can chain it like in this switch statement. It's not something that you really do too often. I think I've used that kind of functionality like twice, maybe. But it's something you may see, so it's something that's very handy. Did it actually print out you aren't young? I didn't actually... It did. So that's wrong. So we do want it to break at the end here, so it doesn't come down to this default and then print out this. So if I go back to that, bug fixing live, people, there you go. So it does what we'd expect now. It doesn't say you aren't young. I could have put the default at the top, but convention says default always goes down the bottom because that's the last condition. But I don't really think it matters. I think you can put default at the top. I don't remember. And I honestly can't be fucked fixing it to try it. You're welcome to mess around with it. So that is it. That is an hour and 17 minutes straight of me talking about logic flow in programs. When you sort of look back, this should all make a lot more sense in your head, just by using, like, closing your eyes and sort of thinking, if this, else, if this, else this. That makes sense in your head. Does it make sense? If it doesn't, so write your branching paths on a piece of paper and say, this, and then put in, you know, a branching path that goes into a branching path that goes into 2 more branching paths. It's all possible. It's all things you can do. Think about loops you do day to day. While there are customers, like I used to work retail, while there are customers in my queue, I'm going to keep bagging groceries. And when there's no more customers in my queue, I'm going to go clean the floor, you know, or something. Think about how you'd use for loops. Like, I want to check all the games in my collection for one I want to play. So start at start, go all the way until I find something I want to play, or I've run out of shit to look at, and just go one by one. You don't want to skip any, do you? That would be a for loop. It would be a while loop if you want to dick around with it. Switches is a little bit more difficult to sort of imagine. It's kind of like a convoluted if statement. Once again, I don't really think you'll be using it a whole lot, but like a basic switch statement with all the breaks in, I've used, you know, a handful of times, a decent amount of times. But without the breaks, using this cascading kind of format, it's so rare. But you get undefined behavior, like not undefined, just weird behavior if you don't sort of keep up to date with the breaks. And yeah, So this is the kind of thing where you can go back and sort of make a really basic menu. And I kind of really want to do it quickly now. So let's see what we can do in 5 minutes. Because honestly, like, it's 9:30 at night and I'm exhausted. So let's go through and do it. Make a menu system. Okay. Enter 1 to hear a joke. So we're going to make a really simple program. Enter 2 to enter your name and have me repeat it. Let's get rid of the enter because it's ugly, and let's put in a dot. See how cool the select is? So 3, 4, 5. To your age and have me repeat it. And we'll say 4 to exit, and we'll get rid of 5. Cool. And I'm going to say your choice. Now, I didn't really explain it, but this thing here hasn't got an end line. So when you press enter to enter the thing, it'll actually create a new line for you. And if you put it in first, it's going to go, here's your thing, and when the cursor to enter it will be down here, and that's kind of ugly. So let's change user age to, let's just leave it as user age. It doesn't matter what the variable name is. It doesn't make sense, but you know, whatever. So let's delete all this shit. Cool. If we could use a switch. No. You know, I am going to change it. So int input equals -1 and input. So if input is, equal to 1, standard cout, you are a joke. Lel. Cool. Else if the input is equal to 2, we're going to ask for their name. So string name is equal to blank, standard cin name. I think that's the way it works. Like I said, I haven't done this in so fucking long. Standard cout. Your name, please. And your name is, I nearly typed in my actual name there. Cool. I'm going to do the same thing. Sorry, I can't type and talk. It's a thing. Cool. And that should be 3. And we're going to keep going while input does not equal 4. I forgot to comment out that bit of code. So let's quickly do that. And we've made a program in, what, like 2 minutes? 3 minutes? It's not a very good program, but let's run it. 1 to hear a joke, 2 to enter your name and have me repeat it, 3 to enter your age and have me repeat it, and 4 to exit. Cool. So 1, tell me a joke. You are a joke, lol. And then we're back at the menu. Tell me another joke. Another joke, you useless program. Okay, let's enter my name. My name is Jason. Your name is Jason. Fantastic. Let's enter my age. My age is 30. Your age is 30. And 4 to exit. That's the end of the program. That is an extremely simple. What's the other option? 2, you can enter stupid shit. I could enter 5. It'll just repeat the menu. I can enter that. It'll repeat the menu forever because I can't remember how to clear the fucking buffer. It's just like cin.getLine, I think. No, I don't remember. It doesn't matter. And there it is. It's a very simple menu. We have a little bit of user interaction. We have a branching path that goes to 4 different options. And it keeps looping on itself. It keeps doing stuff until you tell it to not do stuff anymore. It is the most basic of literal, actual programming. And you can do it. If you're watching this and you're following along, just play around with a do loop. Make something cool. Do some funky if statements. So you say if one to hear a joke, and you go, okay, joke about what? And then have a menu there or something like that. And it has a different joke depending on what you've entered. And it's like another little loop or something. Just try it. You're not going to get anywhere unless you try it. And you're not going to have anything happen if you fail. Your computer's not going to catch fire. You might get a bit frustrated. I can tell you that will happen. But you will never learn unless you actually work on it. Learning the basics of how a program works is fine, but without trying to do it yourself, it means nothing. Syntax is one thing, programming is another. That's what you have to remember. And if anything through this 90-minute rant of programming gets into your brain, it has to be that. You can know how to program, but not know how to program. You can know what the syntax is and how code works and not know how to actually make code. And also remember what if statements are, because they're kind of cool. That is it. I hope you've enjoyed this. Next time, we're going to talk about arrays. Arrays are cool. Arrays are extremely useful. Well, in the beginning, they're kind of useful, but we'll get into that. I hope you've enjoyed this. I apologize for the length, but this is a pretty lengthy topic, and I will see you next time. Goodbye.